All right, it's 5:30, it's showtime. Are you ready? Well, perfect. Thank you for joining us at our 5:30 demonstration. This is our last glass blowing demonstration of the day, and this is going to be a really fun one. This is a special demonstration. This is part of our summer Bring the Heat series, and Bring the Heat is an opportunity for the glass making team here at the Corning Museum of Glass to make something big and fancy and very cool. So this is our first Bring the Heat of the summer, and our glass maker for this demonstration will be Chris Rochelle, and he's going to make a rocket like what we have down here. So we'll talk about that, and we'll talk about our Bring the Heat series a little bit more, but let's get things started. Let's give Chris a big round of applause as he gets going here this evening. Thank you very much. I'll introduce the rest of the team. Helen Tagler will be assisting Chris. My name is Michael. We've got Brad on the camera down here, giving us these fantastic close-up shots. Alexis is up in our AV booth. She's mixing all of the video that we're seeing. Then we've got Brady online because this is a live-streamed demonstration. So this will be on our YouTube channel, and you can watch it on YouTube live right now as well. So once we finish this demonstration, in a week or two, we put the full video on our YouTube channel as well. So we've got a really great, really extensive YouTube channel, and we actually have a backlog of some of these Bring the Heat demonstrations that we've done in the past. But let's catch up with Chris, because he's been hard at work all day preparing for this demonstration. So he's been making a lot of different parts and components, and he actually got started with the gathering, the collecting of glass a little bit early as well, because we only have about an hour to put this piece together. And if he didn't do a lot of work in advance, you would be here for probably closer to 3 hours. So he needed to do a lot of work before we got started here tonight. So he has some glass on the end of a hollow stainless steel blowpipe. This is going to be a sculpture, but it is going to be a blown sculpture, so it is still hollow. Now I see a lot of familiar faces from some of the shows that we've done earlier in the afternoon, so a lot of you have seen probably something a little more traditional, a vase, a pitcher, a bowl, something like that. This is built on the foundation of those same processes of gathering glass, blowing glass on the end of a hollow pipe, but then we're going to add a lot of additional components, and Chris is great at doing a lot of really fine detail work on the things that he makes. So we've got glass, we have a white overlay, and what that means is we started with a small bubble of glass, and then we heat colored rods of glass. So we heat those, and we push that over the top of our initial white bubble, or our clear bubble of glass. And then once we blow the object up, the whole thing will look like it's white, even though it's just a very small percentage of white glass. It's actually mostly clear glass. So he's got a couple layers of clear over the top of the white, and he's expanding this and he's inflating this using an inflation system. So we've got a tube that we can attach to the end of the pipe, and we can blow glass by pressing on a foot pedal. This sends compressed air through the tube, through the pipe, and into the glass. So this is a very convenient way for us to be both shaping and inflating glass all at the same time. But this is the form that he's making. So this is the rocket that he has planned, and he's made all of the fins, he's made the window, he's made all these lights, and he's made the point of the rocket all in advance. So those will all be attached later on. But the cool thing about this rocket is that when it's finished, it's going to be a lamp. So where he puts the lights, where he puts the windows, that's the nice thing about this being hollow. He makes a hole there so that when we put a light underneath, it's going to shine through all of those little windows. I haven't tried this yet, but I have a little flashlight that I keep on my backpack. So if you're here in the audience, we can look at it. We can see what it looks like. Ooh. Ooh. Everybody say it with me. Ooh, yeah. Very nice. Oh, we're going to get a shot of it. Brad's got a nice shot. See, so if you're watching online, if I take that away, and then I put this back in there, it lights up, and the white really allows the rocket to glow nicely. Oh, very good. Thank you, Brad. Now, the other cool thing about this rocket is that if it comes out, it's going to be for sale. So this is the cool thing about this partnership for our Bring the Heat demonstrations. These are in partnership with the Corning Museum of Glass shop. So this is a great way for the artists here at the museum to make something that's a little bit more creative, a little bit more in their style, and then we'll sell it. So we don't typically make things here, our personal work especially, to sell. So this is a very cool opportunity for us. Now we do make some things to sell. We have a limited production line that we'll make. It's called Made, as in Made at the Corning Museum of Glass. And we do sell some of those things. So if you look on the lit pedestals on either side, we have examples of the things that we do make to sell in the shop. But those are not our individual designs. Those don't necessarily reflect our own personal style or our own personal taste. So this Bring the Heat partnership is a time for us to really get to show off our own style. So Chris has been making these rockets. We made the first one, or we made one a few months ago, and we made a rocket because we do a little scavenger hunt here at the museum. So it's a fun thing for kids to do, or adults alike to do. You can do a scavenger hunt, and you can find different items that we hide around in our galleries and in our collection. And Chris made a rocket. He made a space-themed object to be hidden in the gallery. And it's been fun because in doing this, there have been a couple different versions, a couple of variations of these different rockets, different designs, different color applications, and then we've settled on this for this longer Bring the Heat demonstration. So it's been cool to see essentially the prototype of how this has gone and to see how these change over time. So you can see we also already have the initial rocket shape. It's not a very complex shape, but where it becomes complex is making all of these additional components, putting all the fins and things on. But also, Chris does like to make these very detailed and give them some realism. So he will eventually go in and put things like little rivet marks in the glass. Now, I should mention that if you're here in the audience, or even if you're online, if you have questions, get my attention. I'd be happy to answer those throughout the process. If you're watching online, you can type in, and Brady is moderating. He can answer, or he can ask me if he doesn't know. But yeah, we're happy to answer anything that you're curious about. Yeah, why did he use the torch? Yeah, we use this torch to heat specific areas. So we call ourselves glass blowers. That's a very small part of our job. We do a little bit of inflating, but we do a lot of temperature management. So when we use the torch, we're using that to focus heat in certain areas, and we have two different torches. So the big torch that you just saw him use, we call that the fluffy torch. Now he's using a torch that we call the hot torch. You might think, well, that big one looked pretty hot, but this small one is much hotter. This is a mix of oxygen and propane, and we can use this to achieve temperatures of nearly 4,000 degrees. And it's also a much finer flame, so we can really pinpoint what we're heating. And in this case, he's heating the bottom, and we're going to open the bottom up, and we'll attach another pipe onto the bottom. So I think that's his next move. But you'll see him use that hot torch to create really hot areas so that he can go in and create a lot of that fine detail. But we also have compressed air. So we're also cooling certain areas at points as well. So you might see him use this cone tool. This is connected to compressed air, and we can cool glass down with this. Now, we use these all in conjunction with this big furnace where Chris is standing now. This is a reheating furnace. There's no glass in this furnace. It is just a big chamber of heat. So as long as we keep heating the glass, we could work on this for essentially as long as we want. We could work for hours on this rocket. But we all want to go home at quitting time, and you all probably will want to go to dinner. So that's also why we did a lot of the work in advance. It's so that we can make this fairly efficiently. But we could work on one thing for hours at a time, as long as we just keep it hot. What happens as the glass cools is, first of all, it will become rigid. We can't shape it any longer. But if we let it cool too much, it will crack and break. So the entire time we work, we'll never let this drop below 1,000 degrees Fahrenheit. So when we first started, we got the glass out of the melting furnace at 2,100 degrees Fahrenheit. That's about 1150 Celsius. It's the same temperature as lava. So we're talking very extreme temperatures here in the shop. Did you have a question? Oh, Perfect, I got it. Yeah, so the melting furnace, that sits at 2,100. The reheating furnace also sits right about that temperature. We'll adjust it a little bit here and there depending on what we're making, but for the most part, we keep it right in that ballpark. Now, if we were making something really thin, like a fine goblet or stemware, something like that, we might turn the heat down a little bit because the thinner the glass is, the faster it heats up. So sometimes we want to make sure we don't heat things too quickly that it becomes hard to manage. But yeah, those are the temperature ranges that we'll be working with throughout a lot of this process. Now, with that in mind, the white glass that Chris is using looks pretty much white. But when we start adding some of the additional components on, when we start adding the fins and the point of the rocket, and the window even, those will not look their true colors. The red fins will look more brown. The blue window will look more green. And that is just because of how the different colors show their different heats. So it's all about how the light energy is being transmitted through those colors. Yeah. So we've got the form now of the rocket, the body, and this is where we start working on creating some of that detail. So Chris is going to use the torch, and he's going to start heating the line where he wants to essentially carve and push in the rim or the ridge that he's going to put some texture here. Now he's using a glove. We get asked a lot why we don't wear gloves, and for the most part, we don't wear gloves. If we're making a typical vessel, we wouldn't wear a glove. But in this instance, when Chris has his hand next to the glass for a very long time, it's going to get hot. So that's when we might put a glove on. But for most of the time, when we're tooling and shaping glass, gloves really get in the way more than anything else. So we learn what we can and cannot touch. But he's got his hand very close to the glass there to cut in that line. Now, Brad was giving us a really good close-up shot of what the line looks like when he made that indentation. So you'll probably be able to see that really well as we continue to make some of this detail. So these heats that Helen is taking, she's turning the pipe, which makes this a lot easier for Chris. So when she's taking these short heats, she's not trying to change the shape of the rocket. She's just trying to make sure that it doesn't drop below that 1,000 degree mark where it could potentially crack and break. And she's also turning really evenly to make sure that Chris is heating this evenly. So she's really using the full length of the rails of our workbench, so we're not turning back and forth a lot, maybe only heating, 3/4 of the vessel. Yeah. Here, 1 second. It's just, they'll be fine for a few moments. I can come out there. That torch is a little tough for me to hear what's happening just because it is a little loud. So I'll come a little closer because I'll jump in at some point, I'm sure, to help with this, but they don't need me right now. Yeah. Mm-hmm. Yeah, blowing glass, does it affect our health, or how might it affect our health? People think oftentimes about our lungs, that type of thing. It's not that so much. Historically, where the health problems would come in would be from the raw materials. So silicon dioxide, sand, that makes our glass. It's really fine. It's a powder, and it's bad to breathe. So that historically would have been a bigger issue, is that you're breathing some of the raw ingredients that make glass. But for us now, we're far more aware of that. So those are less common issues that we might have. But it's a lot of repetitive, stress injuries, tendinitis, tennis elbow, that kind of thing. Tendinitis or carpal tunnel, people ask us about. But you'll notice at points when Chris is sitting at the bench, we're also always sort of leaning to one side. So to prevent that, we do a lot of different stretching. We try to do exercises to, keep ourselves a little bit balanced. But chiropractors love glass blowers, massage therapists love glass blowers, physical therapists love glass blowers, because it is tough on the body. So, we learn different ways to move around the pipe and to move the glass so that it is safer. There are definitely better postures and ways to do things so that you can hopefully prevent some of those problems. But yeah, it's also just a very active job that we have. So we're on our feet a lot. But yeah, those are some of the bigger considerations that we might have. Yeah, and how about our eyes? Yeah, when we use this torch, that's probably the toughest thing on our eyes, because when we heat the glass really intensely, it gets really bright. We call it soda flare. And if you're a flame worker, if you do glass making over a bench-mounted torch and you work with one of those torches and melting glass at really high temperatures all day long, you'll wear specialized glasses. For us here in the shop, we don't need those so much, and we don't do a ton of work with this torch where it's going to be super detrimental. But we do, at the reheating furnace, have a little shield that's tinted so we can look through that, and that helps with some of the brightness. Especially in this space, we have a lot of natural light, but on a gloomy, cloudy day, it gets darker in here. So it's more just that your eyes are adjusting a lot back and forth between looking in the furnace and then sitting down at the bench in the darker space. But we have an outside company come, and they take readings and measurements of what the light and the UV is coming out of that furnace to make sure that it is safe for us to look at. And it is safe, so that's good news. But yeah, it can be tough just with our eyes adjusting a lot. Yeah. Is it just experience to know how long to keep it in the reheating furnace? Pretty much. Yeah, pretty much. So we do look for a couple different things to understand the temperature of glass. I was just talking about the natural light in here. That means that looking at the color or the glow of the glass is not always so reliable, because on a sunny, bright day, when it's light in here, the glass looks colder. On a gloomy, cloudy day, the glass looks hotter. So the movement tells a better story for us to understand the temperature. But we're not always looking for movement either. So sometimes we're taking a heat, and our whole goal is that it doesn't get too cold to break, but also that it doesn't get so hot that it moves. So yeah, that's just experience. It's almost just a gut feeling, a gut sense that you develop. Helen has been blowing glass for around 30 years, and Chris for 25 years. So you're seeing a lot of experience right here putting this together. And I'm just a baby. I've only been doing this for 14 years. Yeah. So yeah, a lot of experience that you'll see putting this together, and a lot of just fantastic understanding of the material too. So this moment now, Chris is using the torch. He's creating the little rivets at this moment. So he's got just a little tool. It's basically just like a little tiny brass pipe. He's just pushing indentations in to make rivets. I'm not sure how well you can tell by looking at the rocket down here. We've got a fantastic close-up shot. You can see one of the rivets, and you can see as he squishes in how soft that glass is, but it's only hot on the surface where he wants to make that indentation. But I'm not sure how well you can see. I was saying the rocket that we have here, Chris has some other colors that he's going to put on this. So he'll use powders. We can get glass in different forms, and we have these powders that are really fine, and he's going to use a silver gray color that he can basically sprinkle onto the surface and get that powder to stick in the little rings that he's creating. So the powders will go on the very outside surface, but to get the white base of glass, he started with something that we call color bar. We get these long rods of glass color. We break them up into smaller sections. We preheat them to about 1,000 degrees, and then we can pick them up and shape them and put them over the top of the bubble. So these are just two ways that we can apply color to our glass. So I'm not up close to the one that Chris is working on now, but the one that he made previously, and then ones that he's made even before that, he lines those rivets up. So he puts rivets on the top and he puts rivets on the bottom, and he is trying to line them up as closely as possible so that they are vertically stacked. So the other nice thing about the powder that Chris is using is that it actually does leave a little bit of texture on the surface because he's putting this on in a way that towards the end of the process, and then he's not getting it ever too hot so that it's not melting smooth. So it does give this a really excellent tactile experience if you touch it. Yeah, what's your question? Yeah, when would we need to wear the silver shiny coats that we have? So we don't typically wear the silver shiny coats until we're all finished with an object. So when we finish our pieces, we have to put these into an oven called the annealer to slowly cool. If we just let the glass sit out in the open air, I've mentioned this a little bit, it will crack and break as it cools. So we put the glass into an oven called the annealer and it cools it down slowly. Now this is important because where we put the fins on, for example, that glass will be thicker there, right? We have this thick point where that glass is attached. And as glass cools, thinner glass cools faster than thicker glass. So where these inconsistencies in thickness are, the glass will pull and contract, it will create stress, and it will break. So everything gets cooled slowly. But the oven where we put these pieces to cool, the annealing oven, is 966 degrees Fahrenheit. So sometimes we have to reach pretty far into a 1,000 degree oven, basically, so that they can sit in there to cool down. And sometimes we make really big things that have to go in that oven. So if you're the person that catches and holds that piece of glass, you want this big coat so that you can stay comfortable. Sometimes we'll put the coat on. Sometimes we'll just use a sweatshirt if it's not as big. Sometimes we won't use any coat at all, but we'll also catch the piece with some gloves. So the gloves that we have are Kevlar and Nomex. It's essentially the same stuff that firefighting suits are made from, but we've got these big gloves, and we can hang on to a piece of glass that's 1,000 degrees with these gloves for a couple minutes before they start to get hot and uncomfortable. So this piece, because it's not too big, and because we're not going to have to put it too far into the oven, I don't think we'll need any silver coats for this one. But we get asked about the silver coat a lot. I'm not sure if it's just because it's shiny and it attracts people's eyes, or maybe you're very fashion forward and you think, I'd look really good in a silver coat like that. But I think it'd probably get hot. Yeah. So at this point, Chris is working on opening up the side of the rocket. And this is where the window is going to go. So he's using the torch, and then he was also using the tweezers. And essentially, we're just kind of pushing the glass to the side. It's almost like swimming. You push the water off to the side, you push the glass off to the side to make a hole, and then he's just opening this up, essentially with the tension of the tweezers. The tweezers that we have want to spring open, so we can just use the tension of the tweezers to open that opening up. So he'll continue to refine that. But I've been talking about the parts that we're going to add to this, the window, the fins, but that's nowhere to be found. All of the different components that we're going to use, that we're going to add on, are all the way over here. We have a little piece of equipment. We call this the garage kiln. We call it a garage because we make parts and components, we park them in the garage, and then we can use them later. So this garage holds all of the fins, it has the window, and it's holding all of those at about 1,000 degrees. So we'll add all of those components later. But before we do that, Chris has turned on our powder booth, which means we're going to start adding some of that color on the surface. We'll start adding some of that powder. Now, I mentioned briefly that breathing glass dust is bad. So when we use these really fine powders, we have a powder booth that has filters, so it's suction, so it's pulling all of that glass out of the air, and then it's all getting filtered so that we're not breathing it in. So Helen's getting the surface hot, and that will allow the powder to stick. Chris just has this in a little sifter, just like you might use for powdered sugar on your dessert. So he sprinkles this onto the surface, and we've got two different colors that we're using. One is called white smoke, and then the other one is smoked silver. And I don't remember the exact order of operations that he puts the colors on. I mean, this is white smoke, but I'm not sure if we put some of this on at the very end as well. I can't remember. Chris did have, I don't see it up here, so it's maybe on the side of our stage. Oh, no, it's actually on the bench. Chris has a little drawing of the rocket, and then he has all of his steps written out. So a lot of us will do this. We're planning all the steps out in advance, and so he just has little bullet points. So he has on the pipe, so that's currently on the pipe, complete in shape and inflate. Open all the light and window holes. Open the base wider, torch the lines and the rivets, both of the powders, and then attach the windows and the lights. So he's going to do both powders. Look at this. It's like a cheat sheet. Now we all know. But yeah, we'll all usually plan how we're going to make things so that we don't get here and we're, try to figure it out. It's very much like driving somewhere. You have a plan of how you're going to get somewhere before you get in the car. We have a plan before we sit down at the bench. So at this point, this is really great. He's just brushing with a little bit of cloth. He's brushing off some of that smoked silver color. So it's really only stuck in the impression, in the indentations. So he's brushing it off the surface so that we keep the darker color in those lines and we really highlight those designs. So once Helen takes another heat, the color that's left behind, it is going to fuse onto the surface. So hot glass sticks to other hot things, and that very fine powder will fuse onto there. Yeah, you're welcome. Yeah, do you have a question? Yeah, will the glass be powdery or grainy afterwards? It's going to be a little grainy. Yeah, and that's the whole point with when Chris is putting this on. Sure. So I'm going to help Chris out, but if you want to come touch this really quick, you can feel it. Yeah, so it is a little bit textured. So we're going to put the window on, and I'm going to help Chris with this. So we've got the window, it's in that garage, and it's on a little flat plate. So I'll preheat this a little bit before we try to stick it onto the vessel, onto the side of the rocket, because it will be hot. Or it will need to be hot so we don't break it. So the window is sitting in this garage, and it's 1,020 degrees. I'm going to bring this little window out. I'll give this what we call a flash, which is just a really short heat in the reheating furnace. And then Chris has a clear glass rod. He'll stick this onto the window. It gives him just a very fine attachment point so that we're not going to scar up the surface of the window. You got it. He's heating the edge. Helen is heating the side of the rocket. Chris will run over. He actually cut the window. He carved it, so it is a little bit curved as well, so it'll match the curvature of the rocket. Places this down on the side, and then look at that little tiny tap. That removes the window, and it doesn't make any scars on that window. Smooth it out, really push it down with that cork to make sure it fuses. I say we give him a round of applause. That was so cool. Chris also has some of the steadiest hands in the business. If I was putting that window on, I would totally, you've got a hole, right? You got to line it up. I'd probably just totally miss. Yeah. And he drinks coffee. I don't know how he does it. But steady hands, perfect attachment. So there are different ways that we could put that window on, but to make just that little tiny attachment with that clear rod allows him to essentially make what we would call a cold seal. It's a very temporary connection. So he pushed it down, and then it was cold enough that he could just sort of put a little bit of pressure there and just snap it right off. So that gives us a very clean window on the front. So if you come close and you look at this one that's sitting here, there's pretty much zero evidence that that was ever attached. So very clever way to go about adding that little window. That's one of Chris's really strong suits, in my opinion, is he comes up with a lot of really clever ways to do incredibly fine and detailed work. Some other examples of his work down here, he's got some different bowls with different really beautiful flowers, and same kind of thing. He leaves a little bit of the texture with the color, with the powders on these flowers, and they're just really delicate and exquisite and beautiful. So I think all of us that are making some of these different Bring the Heat demonstrations, because we'll have 5 of these all summer long, and 5 different glassmakers from our team will be doing these demonstrations. And I think all of us that are doing a Bring the Heat demonstration have work available in the shops. And so if you are curious, you can go online, you can look at our website, and you can see, first of all, when the different dates are. They're always going to be on Thursdays. So when the different dates are of these live streams, you can see who's making them. If you follow us on Instagram and on Facebook, follow the Corning Museum shops. Is that what it is? Corning Museum shops? Is that the Instagram? Yeah. So we have the Corning Museum of Glass, then we have the Corning Museum shops as well on Instagram. And when this is all done, you'll see a picture of that as well as details about this being sold. Those will all be available online. But you can also just look up Chris on the shops, and you can see some of the other work that he makes. I think what he has in the shop currently are some goblets. He makes these really cool goblets. Some of them look like strawberry stems, very viney, I think. I'm actually not so up on the current inventory of Chris's work, but I've seen Chris make those things and have them in the shop in the past. But he has strawberry goblets, like martini glasses. They're really beautiful. So now he's making the holes for the lights. This is very cool. It's always great when we get some extra power tools in the shop. He's got a drill. It's not a normal drill bit, though. That's a tungsten bit. And we can heat the tungsten, and as long as the glass is fairly stable, we can heat the tungsten and pierce through the surface of the glass. So he's piercing through to make the holes for where the lights will go. That way the light, when it's a lamp, will shine through the different lights. So for the lights, similarly, these lights that he puts on are super, super clean. He used some other small glass rods to make those lights. So I think these are 2 of the lights. So he started with a glass rod that's really symmetrical, and it's really uniform. We buy them in this uniform diameter, and then he can heat it up, and he can basically make the little light the size that he wants. And then he also made a really little tiny constriction. So that'll be where this snaps and breaks. So he'll heat the area that he's going to put the light, stamp it in there, and then when he applies torque, that little fine constriction is just going to snap off. So again, super clever way of going about making these lights. You could get hot glass and you could bring it over and you could just stick hot glass on there, but you'd have to cut it. We can cut through glass with shears, and if you cut through there, it's going to leave a mark, and you'll never get that mark completely away. You'll always, if you look closely, be able to see a little bit of evidence that you cut through the glass. So by doing it this way, really tiny connection point, snap that free, and then completely smooth surface. this is also, as I'm just watching him and looking at the pre-existing rocket, thinking about how clever all of this planning is. He has 3 lights on the rocket, and those lights line up with where the fins are. So then when he goes to put the fins on later, he has basically a way to line up where the fins go. So he's predetermining the thirds now. And that's one of the really challenging things, is to divide this up evenly, just visually, into thirds. But that's another thing that Chris is pretty good at, is eyeballing thirds. So the one fin is opposite of the window, and then everything's just really in line that way. So he's been working on all of those details, but at some point we're going to remove the rocket from the blowpipe that we're working on, and we're going to hang on to it with a secondary iron. We call it a punty. And the punty is going to go where Chris is drilling a hole now. So we'll put a second handle on here, essentially. We'll break the rocket off of the blowpipe that it's living on currently, and then we'll start adding all those other components, and that's going to give us the ability to add the top of the rocket. But he's making a hole in the bottom for 2 reasons. One, we want to be able to put a light in there, so by making a hole now, he can put the light inside. But also, when we put the punty on, the temporary handle, it's going to be what we call a blow punty. So it'll be on a blowpipe as well. It'll be a hollow connection, so that as we're working and shaping, if you need to, you can add a little bit of air to the top. But we also don't want to completely close and seal this object, because if we completely close it and seal it, what happens to air as it's heated? It expands. Right, so if we have this completely sealed and we're heating it in our 2,000 degree furnace, it will start to expand, and it can start to distort and misshape. But also, when this cools down, if we put it into the oven and it's completely cooled and it's completely sealed and it's cooling, the opposite happens. That glass will contract. You have all the air inside, and it can crack and break that way. So a little opening will allow the air to expand and contract and not cause any issues to the rocket. So Chris is heating up that window, and Helen's using that other torch. That other torch, she's just using that to maintain the temperature at the connection, so where the glass is attached to the pipe. That's the last thing into the furnace. It's the first thing out of the furnace, and that means that it's getting the least amount of heat. And if that cools, then the piece can break off the end of the pipe. So again, that's just all for temperature management. So here he goes, places that down, make sure that fuses. Did you see how that just snaps off? So cool. That's so clever. So it seems appropriate. We're making a rocket ship. The view that you see the rocket inside of the reheating furnace, that's technically cool rocket ship glass. We have a little window at the back of the furnace, and that window is called fused silica, and it doesn't melt until nearly 4,000 degrees Fahrenheit. So we have a camera that looks through there, and the camera has fans that blow on it so it doesn't overheat from proximity. But the fused silica glass, it was a product invented here in Corning by Corning Incorporated all the way back in 1934. And when it was invented, they knew a couple things about it. They knew that A, it was very, very clear glass, and then also it melted at this really high temperature. But there wasn't much use for it. So it's actually a couple decades later that it was first used, and it was used by NASA for windows for spacecraft. So it can withstand re-entry back into Earth's atmosphere. So it has been used for many, many spacecraft windows. but then it also works great for us to have a cool view inside of the reheating furnace. Now, that fused silica glass also, the point of it being very clear, that became prevalent even later, but that is the property of fused silica that allows it to be perfect for the core of optical fiber. So if you've been on the phone today, if you've sent a text message, looked anything up, most information now is being transmitted through glass fiber, optical fiber. So very cool that a glass technology invented here, 90 years ago, is how we're all staying connected and communicating every single day. But I like the connection of rocket ship glass, making a rocket. That's fun. So while I've been fielding some in-person questions, Brady's been fielding some online questions. One of the online questions is, why is Chris Rochelle so handsome? Not to distract him. And then there was a follow-up. Another person said, are all glassblowers this handsome? Obviously, I would say that yes, we are. Yeah, I think probably so. This is one glassblower. Did you hear that? It must be a glassblower in the crowd. One person clapped. Yeah. You might be able to guess, those are some of our other glassblower friends that are watching our videos online. Yeah. So this is where we transfer the body of the rocket. Perhaps we may even go so far as to call it a fuselage. We'll transfer this from the blowpipe onto that blow punty that I was talking about earlier. So in the meantime, Helen is just in this holding pattern. She's just taking these short heats. She's using the torch to balance out the temperature from top to bottom. Chris is making that blow punty. So he'll blow through the pipe. It's got a little bit of glass there. That glass forms a bubble, and then he'll pick that open and shape this so that it's basically just a hollow tube on the end there. So this blow punty is a very important connection, and the temperatures are very critical because we need this to stick and fuse and adhere well enough that we can do all of the rest of the shaping to finish the rocket, but it also can't be too hot that it sticks and fuses permanently. So it has to be just the right temperature. The rocket also has to be just the right temperature, but Chris also wants to make sure that this is the right size. He's going to essentially match up the diameter with the bottom of the rocket. Now, he also wants to make sure that he doesn't make this too large or anything, that when he starts putting the fins on, this gets in the way. So a lot of considerations as far as the shaping, the temperature, and then the timing of the two for this connection. Now, even though Helen is holding the piece, Chris is still what we call the gaffer, and that's the lead glassmaker. He's the person calling the shots. So while he's been working on that, of course, he trusts Helen to maintain the temperature here because of her experience and because of their years of working together. But he's also still watching just so that he can sync up the timing. So they do a little trade back and forth. She will deliver or bring the punty and Chris will stick this on. So he'll line this up, place it on, and he wants to make sure that these two pipes are running centered and true with one another. So he's looking at how the pipes are rolling together in unison, looking for high sides. And then to break this off of the blowpipe, we will create a little bit of thermal stress. So I've talked about not letting the glass cool too much. This is where we intentionally cool the glass. So Chris has created this constriction, this tight line in the glass, and that's our breaking point. It's like the line in a chocolate bar. But he'll cool it with the steel tools, a little tap. Look at how easily that breaks off. Yeah, you got the right idea. And now we can start working on the top of the rocket. So that glass, it still breaks like glass would break at home. It is still sharp, it is still jagged. But as he heats that, those sharp edges will just start to melt away. But that opening gets covered up by the nose cone here. How are we doing on questions? Still okay? Yeah. Yeah, we have a whole bunch of molds here along the front of our stage. Most of the molds that we have, we call them optic molds. They change the optic properties of the glass. They change how light interacts with the material, so the way that it's reflected and refracted. So I'll look for a good example here. This piece was made using a mold. This is one of those made line pieces that we do sell in the shop. So this was made using a mold. So we'll put the glass into that mold pretty early on in the process. And when we inflate, it fills in the ridges. So then the glass takes on the impression of the mold. And as long as we work quickly and efficiently, the texture stays evident in the finished piece. But these molds, they don't tell us what to make. So this piece was made with that mold, but also this tall piece over here was made using the same mold. So it is just for the texture. So we can still make a lot of different forms using those, but we have a choice of what the design will be. We do have a couple other molds up here. These are old molds that came out of storage. I think these are old Corning Glassworks molds. And these are what we would call finish molds. So you blow glass into this mold, you open the mold up, and it's done. It's a finished shape. And then you would break it off the end of the pipe. Now, these ones we suspect, we don't know with 100% certainty. I'm sure someone does, but we think that these are they're for like railway lighting. We think that's what these were potentially used for. One of the early products that Corning Incorporated made was railway lights that wouldn't break. So we've talked about this thermal stress, these thermal dynamics of glass. What was happening was the railway lighting would basically get hot from the light inside, and then if it would snow or rain, that would cool the glass down quickly, and then it would crack it, and then suddenly you don't have any signal lighting on your train tracks, which could be problematic. And Corning Incorporated made glass that was not going to break when that happened. So we think that that's those molds are for. We don't know, again, with 100% certainty, but they're really cool. They're very fun to use. We don't really use them for any of our demonstrations, just because it'd be a really short demonstration if you came and we gathered glass, blew it into the mold, and then we were done. Now, the other thing that those molds are good for is that we can affect the color. So we can put the bubble into one of those molds, and then we can melt the texture away, but we can get these line patterns on the surface of the glass. So we go into the mold, and it shifts the density, creates more and less dense areas of color. This one, we went into the mold 2 times. So we went in, twisted the color up, twisted the texture, went back into the mold, and this gives us this beautiful, almost crosshatch pattern. So we can use those molds in a lot of different ways. But those are typically made out of aluminum or bronze. We could use steel molds. We can make molds out of plaster. We can make wooden molds. So if we were ever wanting to make something that was really square or have really geometric sharp corners or edges, we would have to make a mold for that. Or it would make our lives a lot easier, at least. So this is now the nose cone. So Helen brings some glass over. This is really hot. So you can see how it wants to drip and flow. So we drop it from above right onto the top. And then Chris will shape this up into the pointy shape that he needs. So he's using a metal tool. We call this a tag, a metal paddle. Now, the very point on the top of the rocket, this is actually another pre-made part. That will be the very last thing added, because this long, narrow bit of glass is going to heat up really quickly, and then it can start to bend and move around and get out of control. So that will be the very last thing. So that's, again, one of the things that we think about often, are the order of operations and how are we going to make the most stable piece that is the easiest to work on. If you put that on at the beginning, then you really have to struggle and fight through that moving around and heating up rapidly. So another online question is, how many times can we recycle glass? Now, glass technically is infinitely recyclable. You can just keep remelting it. We do recycle a fair amount of our glass here. If it's clean and clear, we can recycle it back into the melting furnace. If the glass is something that we sweep up off the floor, or if it's little colored bits, we wouldn't want to mix that into all of our clear glass in our 1,000-pound furnace. So we wouldn't recycle that here. We do send it off, though, to the recycling center. So a lot of that glass ends up getting ground up and mixed into concrete and asphalt. So when we're recycling our glass, we don't typically recycle glass more than one time. So we could make a clear object, we could recycle it, remelt it, but we wouldn't typically then want to recycle it another time after that. The soda ash that we mix in to lower the melting point of our glass, that can melt away over time, or it can burn out, essentially. We would say it burns out. And then you start getting these inconsistencies in the glass chemistry. And sometimes that ends up being visible. You get these striations in glass. So we typically would only recycle our glass one time. Now, if you were working at a big industrial recycling center, you might reflux the glass. So if you know that you're adding however many pounds of glass back into the furnace, you could figure out, we need to add this much soda ash, this much flux as well. But we just don't have that scale of operation, and we're never recycling the same amounts, so that's not something that we would figure out. But we try to recycle as much as possible. Now, we will sometimes do some of our normal demonstrations just out of clear glass, because we, between our two different glass blowing demonstrations, make something like, I think we have 11 demonstrations in each place. So 22 shows a day. That's a lot of glass to have to dust. So sometimes we'll just make pieces intentionally clear so that we can recycle them. All right, but now we're going to start adding the fins onto the side of the rocket. So Chris is heating where this fin is going to go. So he's heating vertically where the fin's going to attach. And he's doing that, again, right in line with one of those windows. They'll do a little bit of trading back and forth. So Helen's going to take a short flash. Chris is heating the part of the fin where it's going to attach. So he's been heating the part of the rocket where it will attach. He's heating the fin where it will attach. So he's going to get a very good, what we would call a hot seal, a very good connection where both parts are hot and sticking together really, really well and really permanently, which we need because the whole rocket hinges on these attachments. So she'll bring this over. Chris lines it up just in line, places that down. Helen does a little bit of changing the angle here so that adjusts and it sticks along the whole length of that heated edge, and then that punty breaks right off. So, another round of applause for another great attachment. So Chris will take a few moments to make some adjustments there. While those connection points are still really hot, he has a little bit of time to adjust the angle of the fin We'll use a wooden paddle for this. The wood is soft on the glass, and it's not going to pull a lot of heat out. So if we use the metal tool at this point, just because that fin is not so hot, if we use one of those tools that pulls a lot of heat out of the glass, we could cool it faster than we want. So he'll adjust that, make sure it's running really straight and true, and then he'll start preparing to do the next fin. And I think he'll pull the tip of this fin out a little bit too. Now, where we break that fin off, it does leave a little mark, and he'll go in and he'll refine that. And I'm not sure if he'll refine that now or if he'll refine all of the fin tips at the very end. But that's one of the other things that he's going to be watching is how are those fins looking in relation to one another so that this is going to sit straight. One of the nice things about a tripod is that it's always going to sit, but if you put one of these on at the wrong angle or if you pull it longer than the other, then it'll lean a little bit. But maybe if it leans, that's just predetermining the trajectory to outer space. Maybe that's all. Get to orbit. But again, a lot of back and forth, heating both of these parts. You'll notice too, there's not so much communication between these two, and that's both just because they understand the steps, they know the timing that's required. They've worked together a lot. So here we go, second fin. Look at that, 2 fins, very nice. I love the design of this because it does have this very sort of retro style of, like almost like a Jetsons rocket. Very curvy and beautiful.
Hey, Michael?
Yes.
Can you just speed up the rose petal crimson on my left when I go for a flash? Just flip the torch for me.
Yep. You're welcome. So we've got some metal crimps here. And we can use these to, pinch and pull and manipulate glass. And this is what I was talking about not cooling the glass too quickly. Chris asked me to preheat those with the torch so that he can use those tools, again, without fear of cooling the glass too quickly and potentially breaking it. Once this third fin goes on, this is where the view inside of the reheating furnace gets exceptionally cool. And 3 fins. Very nice. So he'll go through a few steps to refine the tips of the fins. Pull those, stretch them out a little bit, just so they're a little bit thinner. Right now they're still fairly round. So we'll probably make those all a little bit sharper before we add the final piece, which is the tip of the rocket. Now, when Chris is spending a lot of time heating and working on one side, we want a little bit of movement in that punty connection. If we have a little bit of movement, we know that it's not going to be too cold that it'll break, but it can start to sag and slump just a little bit. So taking a moment now to just recenter everything, and that's going to make it easier to make sure that those fins are running true, so this is all sitting straight. So again, this is Chris Rochelle. He's working on this cool rocket. It's going to be a lamp eventually. And this will be posted, the photos of this will be posted online on our Instagram, on our Facebook, the Corning Museum shops. And the full video of this full live stream video, this will be posted on our YouTube channel as well. And we have 5 of these Bring the Heat demonstrations throughout the summer. So 4 more after today's. They'll all be on Thursdays. They'll all be at this same time, and they'll all be live streamed as well. And all of those pieces, as long as they come out, will go for sale in the shop too. So a really good way to highlight the Corning Museum of Glass team and their skill and their artistic sensibilities, their style. I forget the specific dates, but that's all on our social media and on our website as well. The next one is Eric Goldschmidt. He's a flame worker, so it's glass making over bench-mounted torch. I'm not exactly sure what that one will be. I haven't talked to him about it. I'm not sure what he's going to make. I'm going to do one. I'll do one in August 1st. That's exciting. Eric Goldschmidt, July 25th, 5:30 to 6:30 Eastern. Mine is August 1st. Katie Hubbs, August 22nd, and Jesse Rassid, September 5th. So we're all excited. We've all been trying to practice and do some prep work for those demonstrations. Yeah. Sorry, one more time? Oh, yeah. Sure. Yeah. Uh-huh. Yeah, what's the larger scale commercial use these days for handmade glass, since we're not making the bottles and the light bulbs and the things like that, jars. There is still larger scale commercial hand-blown glass. Sometimes that's even still like very fine goblets, stemware. However, it's not done like this where Chris would sit down and make the whole object. It is a little bit more of an assembly line. So he might gather the glass out of the furnace, he'd blow into a mold, he'd hand it off to somebody else. They'd put the stem and the foot on, they'd hand it off to somebody else who'd break it off the pipe. And then the finishing is typically done by a means, we call it hot popping, but you basically can heat and chill the top and you can remove the edge or remove the top section of that bubble from when it was blown into a mold, and then it can be finished very quickly as well. So it would be more of an assembly line. You might have just one part of the job that you do, and that's what you do all day long. But I have friends who work in commercial lighting, so hand-blown commercial lighting, very high-end lighting. So I'd say that's one of the larger commercial uses still these days. But yeah, there are still factories all around the world that do some amount of handmade, production glass for sure. Yeah. Even all of us do a little bit of production for the most part. I make cups that I sell in the shop here, and I have a mold that I use for part of the process, and then part of the process is all hand finishing. So yeah, I'll do that all day long. How many rocket ships do I think that Chris will make? I think this is a limited series of rocket ships, but who knows? Maybe if he starts selling a lot of rocket ships, then maybe Chris will make more rocket ships. Yeah, that does happen sometimes. Yeah, if you make something and then you sell it and more people want one, then yeah, you'll make more of them. But yeah, we'll see if it sells. I would like this. Sure. So I'm going to hop in here as well. Helen has the top of the rocket. Chris is going to grab the top of this. He's been torching where this is going to go. And I'm going to remove this. So I'm going to tap this off of the pipe. So now Chris can grab that. I'll get this out of the way. Yep. The tip of the rocket. Now that's a really hot connection, so it's really like a hinge right now. So we'll let that settle down where it was attached. And there we've got the tip of the rocket. I say we give him another round of applause. So cool. So as I mentioned before, that's the last part. So I just heard him say to Helen, you can go ahead and suit up. So this is where she'll get dressed to catch the rocket, loaded into that 1,000 degree annealing oven. Well, 966 degrees if we want to get real specific. So Chris is going to balance out all the temperatures using the torch, using the reheating furnace, taking very short heats, allowing everything to homogenize. And no silver suit for this one, but Helen does still put on a protective jacket. So she's got the silver, or the protective jacket. She'll put the gloves on, as well as a face shield. Again, we're going to put this into a 1,000 degree oven. And I'm sure that some of you have baked cookies at home or cooked anything at like 425 and you open the oven, you get blasted with heat, and it is a little uncomfortable for a minute. Twice that, at least twice that here. So she puts the face shield on. That helps maintain eyebrows and things like that. So again, just making sure everything is really stable. The points of those fins where they're thinner will cool faster, so equaling those temperatures out. And if this comes off really cleanly from that punty, they'll fire polish the bottom as well. So they'll remove any potential sharp spots that are left behind. We'll just melt those away with that hot torch again. Now, there's a little bit of superstition in glass making, and that's that we won't celebrate until we put this safely into the oven. So when we break it off, we don't clap then. We wait until it's in the oven, and then we clap. Okay, so we'll all refrain from clapping. But water creates that stress. Helen's got her hands under there just in case it comes free before we are expecting it. Little tap, breaks off perfect. We fire polish the bottom. Helen will get it over to the oven, dodging molds and floor vents. Sets it down safe and sound. It sits really straight. Beautiful job. Fantastic job. That is Chris Rochelle, Helen Tagler, Brad on the camera, Alexis upstairs, Brady. My name's Michael. That's going to wrap it up for the evening. Be sure to tune into all of our other Bring the Heat series. We hope you have a great rest of your night. Thank you so much.